Hi, this is Eric, and today we're going to be going over a quick problem on frequency response. Okay, so you have an LTI system with impulse response given here. Delta of n plus 3 delta of n minus 2. Okay, and you input into that LTI system delta of n minus 1 plus delta of n minus 2 plus this sinusoid. All right, and I want to know the output. Okay, easy enough. So we have sinusoidal input. We're probably going to want the frequency response. So let's go ahead and get the frequency response. If you watch lecture videos, you'll know that you can get the frequency response from the impulse response. And here's the formula to remind you. This is on page 196 of your book. Okay, so let's go ahead and use the formula to get the frequency response of the system. Order M is 2 here. H, K. All right. So let's go ahead and expand this sum. K starts at 0 times 0. Okay, next K is going to be a 1 times a 1. Last K is a 2. I might run out of room. E times a 2 there. Okay, yeah, you can see that. So, well, okay, let's plot our impulse response, sure. So, at 0, it's a 1. At 1, it's a 0. And at 2, it's a 3. Okay, so H at 0, it's going to be a 1. Times e to the j 0, well, that's going to be a 1. 1 times 1. H at 1, well, that's going to be a 0. 0 times whatever, that's going to be a 0. Plus H at 2. Okay, that's going to be a 3. E minus j omega hat 2. So here is our frequency response for the system. Notice it's a complex number and it's a function of omega hat. Okay. So let's finish off this problem. You might be wondering, oh, well, what do I do with this stuff? Okay, it turns out, since this is an LTI system, you can go ahead and input this part of the signal into the system, get the output. You can input this part of the signal through the system, get the output, and then add the two outputs. And you can do that because this is an LTI system, linear time invariant system. All right, so if you put this part through the system, you get the output by convolving it with the impulse response. Okay? And if you put this part through the system, it's affected by the frequency response of the system. So the amplitude is going to change and the phase is going to change according to the frequency response evaluated at that frequency. Okay, so that was a lot. So let's go ahead and write out what the output would be here. Okay, actually, first, let's evaluate the frequency response at frequency pi over 4, okay? Omega hat pi over 4. Okay, well, here it is. Notice, well, e to the negative j pi over 2, well, that's just going to be a negative j. You can double check that by going on the imaginary and real plane. Okay, if you go on negative pi over 2, well, you're going to get a negative j. So, here is the frequency response evaluated at pi over 4. So let's get the magnitude response evaluated at pi over 4 and the phase response evaluated at pi over 4. And that'll tell us how the magnitude or the amplitude and phase change. Okay, so magnitude response, magnitude of this, okay, that's going to be a real part squared plus imaginary part squared, square root of that. It's going to be a square root of 10. And if you go ahead and put this in your calculator and you go to polar form, it's going to be a e to the minus j 1.249. If you can see that, and that's in radians here. So the phase angle associated with this complex number here is going to be a minus 1.249. Okay, so I'll give you a second. Maybe you can pause the video and take in all this. Now let's go ahead and write the output. We have the magnitude response evaluated, let's do magnitude response evaluated at pi over 4, that's a square root of 10. And we have the phase response evaluated at pi over 4. That's going to be a minus 1.249. And this is in radians. Alright. So let's go ahead and write what the output would be. Remember I said earlier, this part of the signal convolved with the impulse response. And then the output when you send this sinusoid through. And when you send this sinusoid through the system, the amplitude is going to be multiplied by the magnitude response. And the phase is going to be added to, you're going to add the phase response to the phase. So you're going to add this to the phase. So it's going to be 5 times the magnitude response evaluated at pi over 4. Frequency stays the same. And it's going to be plus the phase response evaluated at pi over 4, of course. So, well, we already evaluated this stuff. That's going to be a square root of 10. And this is going to be a minus 1.249. Okay, so let's go ahead and convolve these two. If you watched the previous video, you know how to do this. All right. Don't forget about the sinusoidal output. It's going to be a 5 square root of 10 times cosine minus 1.249. Okay. There's your answer. So in summary, the key point to take away is you can send this part through this system, get the output, this part through the system, get the output, add the outputs, okay? When you send a sinusoid through, the amplitude is multiplied by the magnitude response evaluated at that frequency, and you add the phase response evaluated at that frequency to the phase, okay? And that's what you can see. Magnitude response times the amplitude, phase response plus the phase. Okay, hopefully you got it. Thank you.